What's up, guys? This is 8.1, the same exact section we've been on all week, but it is part 3. We're finally moving on to simplifying complex rational expressions. So what the heck is a complex rational expression? Well, we should know that a rational expression is simply a fraction. A complex fraction or a complex rational expression is when you have a fraction within a fraction, right? Pretty crazy. Now we've already done this before. Now what do I mean by that? Like we've already done something like, let's say 2 over x divided by let's say 8 over x, right? This is really a fraction within a fraction, but it just has a division bar or a division symbol instead of the fraction bar. In other words, this right here could be written like this. This is what we call a complex rational expression. So whenever you are faced with a complex rational expression, all you have to do is rewrite it like this. And then once it's rewritten like that, then you know that you could change the division to multiplication and flip the second fraction. So the 2 over x stays the same. The second fraction does change to a x over 8. And then you could cancel the x with the x and the 2 with the 8, leaving you a 1 up on top and a 4 on the bottom. So your final answer would be 1/4. So again, this is a complex rational expression. The only thing new about today is the way this looks, because you've already dealt with a fraction divided by a fraction. So when you do have a complex rational expression, simply rewrite it like this and then do your magic. Factor, if possible, to get multiplication to cancel things out. So I do want to go through the examples in the book. The first example is on page 532. Well, it's example 6 that I want to look at. I mean, if we went through example 5, that's just regular multiplying two fractions. And of course, you factor. Oh, this you can't factor. This you factor everything, and then cancel once it's factored. So we already are good with that. Here's an example where you're dividing by a fraction. So this guy ends up getting switched like this, right there. And then you factor everything and then you cancel. All right. So it's always about factoring first to get the multiplication, and then you cancel. Now, the ones I wanted to look at, today's part that we're looking at is complex fractions, complex rational expressions. And it says right here, a complex fraction is a rational expression that has a numerator and denominator that's also a rational expression. So yeah, you have a fraction as your numerator in this fraction, all right? So all of these are really easy to simplify. So let's take a look at this guy right here. We're not used to seeing it this way. So what do we really have here? We have a fraction divided by a regular 5d. So let's actually write this out. Let's write down the fraction c over 6, the division sign, and we have a 5d. Okay, so when you have a fraction divided by a fraction, and now you're thinking, wait a minute, that's not a fraction. Well, technically it is. I could put it over 1, right? So what do we do with that second fraction? You flip it and you change the division to multiplication. So the first one stays exactly the same. The division changes to multiplication, and this guy has to get flipped. So you end up with a 1 over 5d. After you do that, you try to cancel out anything. There's a c up here, but there's no c's on the bottom. There's nothing to cancel. So your answer will be these two fractions multiplied together. And you just go top with the top. 1 times c is c, and then 6 times 5d is 30d. So that'd be your answer for that complex rational expression. Pretty easy, right? Let's go over these examples that are definitely more fun. So right here we have this fraction divided by this fraction. Okay, so let's see what the book does. They take that top fraction, I'm going to circle it in blue, divided by the bottom fraction, I'm going to circle it in green. And instead of having it written vertically, they write it horizontally. That's exactly what I'm telling you to do. So we have our top fraction as the first fraction. Instead of this division bar, they put the division symbol, and then they take this bottom fraction and write it right here. Okay? So it's really the only real thing that we're learning today is how to change this nasty looking complex rational expression into what we're used to seeing, which is a fraction divided by a fraction. But this is really a fraction divided by a fraction. It's written vertically, we're rewriting it horizontally. Why do we rewrite it horizontally? Because we know that when we divide by a fraction, you really change that to multiplication, but you flip the second fraction. So that's why the 4 is now up here on top, and the a squared plus b squared is now down here on the bottom, and there is multiplication between the two. So the question now is, could I cancel anything out? Well, there's the binomial a plus b up here, but there is no binomial a plus b down here, right? There is none. Even though it looks like a plus b, it's really a squared plus b squared. Those are different, right? And if you're thinking, oh, maybe I could factor it, you cannot factor it. If it were a squared minus b squared, then you could rewrite it to a plus b, a minus b, because that would be a difference of two squares. But a squared plus b squared is not factorable, okay? You just cannot factor it. So you can't cancel this with that, can't do it. The only thing you could actually cancel is the 4 up here with the 4 down there. So your final answer should be the a plus b over a squared plus b squared. There it is, a plus b over a squared plus b squared. So that was one example. If you turn to the next page, if we actually had the book, but we don't. So let's go to page 533. There's another example of simplifying a complex rational expression right here. Okay. So again, what the trick that we're learning today is writing a vertical complex rational expression, rewriting it horizontally as a fraction divided by a fraction. That's exactly what they do right here in the book. This top fraction becomes the first one, divided by, there's a divided by. The bottom fraction is what the fraction that we're dividing by. And again, the division changes to multiplication. This second fraction has to flip. So the 4x is going to go down here, the y minus x is going to go up here. Look, 4x down here, y minus x up here. And then you go about factoring, if possible, to get multiplication to be able to cancel things out. So when we look at this, nothing to factor, this, nothing to factor, this, nothing to factor, this, it is a difference of two squares, all right? A difference of two squares. We need to know how to factor that. Whenever you have x squared minus y squared, whenever you have a perfect square term minus a perfect square term, you could rewrite it by square rooting them and putting the answers in both of the binomials. So the square root of x squared is just x, the square root of y squared is just y. So you put an x and a y in both of your binomials, and one has to be a plus symbol and one has to be a minus symbol. That way, if you were to distribute, x times x is x squared, x times minus y is minus xy, plus y times x is a positive xy. The minus xy and the positive xy cancel out, and then positive y times negative y is negative y squared. So this is why you need a plus and a minus so that the middle term could cancel out. Anyways, that's a trick we need to know how to do. We need to be able to recognize that there's a difference of two squares, and we need to be able to factor that. Let's follow along with the book. As you could see, I already factored it above, but they factored this. They changed it to this. Again, square root of x squared is just x, square root of y squared is just y, 1 plus, 1 minus. You're good, that's factored. And then you could cancel out anything like the x minus y on the bottom cancels with the x minus y up here. And the x on the 4 will cancel out with one of these x's. So there's your final answer. All you have to do is put what's left over together. X up on top, x plus y on the bottom with the 4 in front, and this negative 1, you could just put it as a negative sign at the start of your fraction. Now they did not put the negative 1, they did not put the negative 1 over here. I would put it out here and leave this as a positive x, but they just put that negative sign with that x up on top. Both are totally fine. Anyway, we've gone through the examples in the book. We have some more examples down here. This is your actual assignment right here, okay? We're doing 1 through 11 all, okay? We've already simplified all these other types of problems. The only two new ones are 10 and 11. One option is to pause the screen here so you could jot down the questions, or you could look at the PDF that I'll be attaching to this post on Edmodo. Before I let you go, I want to do a couple of more challenging ones, or more fun, as I'd like to say. Let me get this one out of the way for a little while. Let's do this one first. Okay, so the first thing to do would be to rewrite this as, instead of vertically right here, a fraction divided by a fraction, let's write it horizontally. Okay, and now what do we know? That if you do have a fraction divided by a fraction, you need to take that division and change it to multiplication and then flip that second fraction. So the first fraction's this guy's gonna simply come down right here. And the second fraction we're gonna flip. I don't want to confuse anybody, but as I flip, I am going to factor already. So this bottom one that I'm going to write up here, I'm already going to factor it. I'm going to rewrite the bottom one up on top, but in factored form. X, and you think what times what is -2, that if you combine together is -1. Oh, that'll be a -2 times a +1. So I've factored this one and I wrote it up on top since I'm switching them, right? I want to take this quadratic trinomial, x squared plus 10, oh, you know what? I forgot the x. I'm sorry. Plus 10x plus 21. I am going to take that one and write it factored, but as the denominator, because of course the numerator has to go down to the bottom. Let me factor it as I move it. Put an x right here and an x right there. And let's think, what times what is 21? That if I combine together is +10. And we should all be able to get that +7 times +3. 7 times 3 is 21. If you combine them together, it does give you 10. So I still need to factor this first fraction, okay? So let's do this. More space here. Let me bring this down here, okay? Let me bring it down. It's easy for me to do. I just like copy it and paste it, but you guys have to actually write each step. Now the first fraction, what I'm going to do is I'm going to factor it. So x squared minus 9, that is a difference of 2 squares, right? I could square root that, I could square root that, and I could plug it into my answer format, x plus 3, x minus 3. Or you could think of it the old school way. What times what is your c value that if you combine together is your middle value, which means 0 because there is no middle value. So that'd be a +3 times a -3. Either way, you should be able to factor this. And this denominator, I could pull out a GCF, right? You could pull out the GCF of 6. So if I pull out a 6, what would be left over on the inside? A x minus 2. So as you could see, I've completely factored everything. Everything's been factored. Now it's time to cancel, all right? So what do we have that's alike both on the top and the bottom? Well, as I could see, this x minus 3 up here in the numerator, I have an x plus 3 down here on the denominator. So they're both identical, x plus 3, x plus 3. I'm going to make them completely cancel out, disappear, no more x plus 3s. What else? We have x minus 2 down here and x minus 2 up here. Cancel the x minus 2 with the x minus 2. Let me use different colors here. Bam, bam. And the x minus 2s are gone. Is there anything else that we could cancel? The answer is no. So our answer to this complex rational expression is the fraction with the binomial x minus 3 up on top, and also the binomial x plus 1 up on top, over the number 6 times the binomial x plus 7. There's your final answer for this complex rational expression. Let's do one more, shall we? I know you're thinking, gosh, this is already way too long of a video. Hey, so what? Let's keep going. So we're going to rewrite the top fraction as just rewrite it, a squared minus b squared divided by b over 3. And then instead of this division bar, I'm going to put the division sign, and then I'm going to write the bottom fraction b squared minus ab over a squared. So we're going to change the division to multiplication. How about this? We already know that this isn't going to change. I'm just going to bring it down. However, to save some space on the work that I'm showing, I'm going to factor this first fraction as I bring it down. So a squared minus b squared, that is a difference of two squares, okay? Difference of two squares. So I could rewrite it in factored form as a binomial times a binomial. The square root of a squared is a. The square root of b squared is b. So you put an a and a b, a and a b. And since it's a difference of two squares, there's no middle term. It's not a trinomial, it's a binomial, which means that you must have different signs, a plus and a minus or a minus and a plus. It doesn't matter as long as they're different. So this first one factored to this. Now the b over 3, there's nothing I could really do about that. Let me just bring it down. You can't really factor it. The division, I'm going to change it to multiplication, which means I have to flip the second fraction. So this second fraction is going to have an a squared up on top, and on the bottom I will have the b squared minus ab. Now I might as well recognize that this is a binomial, two terms, and both terms have the b. I could pull out a b from both of them. I could pull out the GCF of b. So when I pull out the GCF of b, imagine that. If I pull out a b from here, there's only going to be one b left. So let's put that 1b in there. And if you pull out a b from here, you're going to have a minus a left. So put that minus a right there. So I hope you guys saw me or understood what I did. As I rewrite my fraction, I factored, right? So now that it's all factored, now I could cancel whatever's alike on top and bottom. So we're thinking a squared. Is there any a's down here? No, there's not. Okay, well, how about a plus b? Is there a plus b down there? No, there's not. Is there a minus b? Well, there's a b minus a. Is a minus b the same thing as b minus a? No, it's not. So check this out. First of all, b and a, that's not alphabetical order. So let's do this, all right? Let's actually rewrite everything, but I need to switch this order. So instead of it being b minus a, I need to rewrite it as minus a plus b. Okay, so let me do that. So here it is, minus a plus b. Now it kind of looks like a plus b or a minus b, but it's still not the same thing. You see, over here we have a positive a, and that's a negative a. And over here we have a negative b, and that's a positive b. So now that I've switched the order, I want this to be a positive and that to be a negative, which means I'm going to factor out a -1 or a negative sign, okay? So what I'm going to do is I'm going to take a negative sign and pull it out of both, putting a negative sign out here. It's like factoring out a -1. So for my denominator, this b times that minus a plus b, it's going to become, let me just rewrite the b, and in the parentheses, I will have positive a minus b. That's if I pull out a -1. So in the denominator, I really do have a negative b times a minus b. So I have factored out a -1, so I could just scratch this one out because I already rewrote it. So now, finally, I do have a minus b up here. I have a minus b down here. So I will be able to cancel the a minus b with the a minus b. So there's our answer. What's left over? Well, we have, let me write my fraction bar. We have the a plus b, and then we have an a squared. Let me put the a squared out in front. Where did I get the a squared from? From here. This and this are on top, so they're right here written up on top. On the bottom we have b to the third times negative b. Well, what's a positive times a negative? It's a negative. So we have a negative b, and b to the third times another b is a b to the fourth. So this is your final answer for this complex rational expression. So I went over some very hard questions. I expect you to be able now to do numbers 1 through 11 on page 533.